Hello everyone. Right, so can you please put today's date in your books, please? I think it's the 24th, but whatever date you're doing it, and the learning objective. And could you pause the video while you're doing that, please? Right, that's learning objective and date done. So we're going to look at today, as we can see, using tree diagrams to find probabilities. But before we do that, I just want to do some revision on sort of adding and multiplying fractions. Now, adding, I'm not really going to do anything on that. Just remember, if you've got sort of 3/5 and you're adding 1/5, it's going to be 4/5, isn't it? The denominator stays the same as long as the denominators are the same, okay? If you're not too sure about that, you really do need to look that up yourself, okay? Right, multiplying fractions again. So if you've got something like 2/5 and you want to multiply that by 3/5, remember when you're multiplying fractions, you're just multiplying across. So you're timesing those. So 2 times 3 is 6. 5 times 5 is 25. So it becomes 6/25. So you're just multiplying across the top. You're multiplying the numerators, multiplying the denominators, and very often you can simplify from there as well. Okay. Again, so they're straightforward there. Sometimes you can get, if you're having to multiply trickier numbers. So here we've got 13. I think that's 13. Yeah. 13/15, and you're multiplying that by 10/11. What you can do is you can cross simplify. So if you go across from here to here, okay, you can simplify that. So what goes into both 15 and 10, 5. So I can simplify that to a 2. I can simplify that to a 3. So now we're still timesing across as normal. 13 times 2 is 26. 3 times 11 is 33. So we can just cross simplify to make it easier. Otherwise, if we don't do the cross simplification, what we're left with 13 times 10 is 130. And then we're doing 15 times 11, which off the top of my head I think is 161. Okay, and then we'd have to simplify from there. So often, if you can cross simplify first. Okay, the same with this question below. If, for example, you had 31/50 times 5/62, instead of having to do 50 times 62 equals whatever that would be, and 31 times 5, again you can cross simplify. Now I can see here that between this 5 and the 50, they go into each other. So 5 goes into 50 10 times and itself once, and I can see 31 goes into 62, so I can cross simplify there. That goes into itself once, twice. So in the end this becomes 1/20, so it's 1/20. Otherwise you so I'm not too sure whether you've learned how to do that before. It's a useful little trick, and it's something actually you should be able to do by now. So there will be a few questions on those, so have a go at those in a little while. Okay, right. Now let's have one of the things we need to understand today is about independent events. So two independent events, if one is happening, does not affect the probability of the other. And actually the work we'll be doing today will be on independent events, but the work we'll be doing the next lesson will be dependent. So let me just give you an example of that. So if I've got 4 spades, 2 red, 2 of each suit in a pack of cards. Okay, so I'm going to then put those face down. Okay, put those face down. Okay, there. Now, I have been given two chances to find a red jack. I've got 2 chances to find a red jack. So we can see here, my first attempt, if it's independent, it remains a 1 in 4 chance, okay? A 1 in 4 chance of me picking up a red jack, okay? So I'm going to have a go. There we go. I've picked up a black one, okay? I've picked up a black one. Now, if I don't put that back, then this has changed my probability of getting the second one, isn't it? It's both of them, but 1 in 4 chance for the first go, okay? If I'm putting this back, now each chance is independent of each other. So this is, I've put it back, so now the second chance is independent of the first one. It remains 1 in 4. But if I keep that out, if I keep the jack out and I don't put it back, now it has, the probability here is dependent on what's happened on that first go. Because as you can see now, I know there are 2 red jacks left out of 3 in total. So I've changed that. So my second chance is dependent on my first chance there. That's the sort of independent and dependent. So the questions we're going to be doing today, basically, it's always something that you're always putting it back. So if the question is asking about picking out balls from a bag, after you've chosen one, you're putting it back in. So each time it's an independent from it's not dependent on what happened previously. Okay, independent. It's in the textbooks. Have a little read on page 186 about what that means, and there'll be a few little questions on it as well. Right, so let's move on. Right, to find the probability of 2 independent events, multiply their probability. Multiply their probability. What I'd like us to do, please, can we write that down in our books? Can we write the sentence down in your books? Pause the video while you do that, please. Right, so let's just give you an example of this. So the most obvious one to use is a dice, okay? So the probability of me rolling a 6 on a dice is, of course, 1 in 6, okay? So if I want to ask the probability of me rolling a 6 twice on the trot, so I'm going to say in advance, right, I'm going to roll 2 6s, one after each other, okay? To find the probability of 2 independent events, multiply their probability. So the probability of me rolling a 6 first time, oops, there we go, is 1 in 6. And the probability of me rolling a 6 the second time is also 1 in 6. Now, because they are, in order to calculate the probability of me rolling 2 6s, one after each other, I multiply those probabilities. So 1 times 1 is 1. 6 times 6 is 36. So it's actually a 1 in 36 chance of rolling 2 6s. If I was to roll the 2 dice together, same thing, okay? The chances of rolling 2 6s are 36, 1 in 36, okay? So I'd expect to do it 36 times in order to manage to get it done once, okay? Right, let's move on to, let's try that also with cards, okay? Cards. So the probability of me picking I'm going to have 2 attempts. I have 2 attempts to pick a diamond. 2 attempts to pick a diamond in a pack of cards. Now, remember, there are 13 diamonds out of a pack of 52, and that's simplified as 1 in 4. And of course, diamonds are 1 suit out of 4 different suits. So it's a 1 in 4 chance of me picking a diamond in a pack of cards. So what is the probability of me doing that twice? Okay, of me doing it twice. I'm going to have 2 goes, and I need to get a diamond both times. And after the first go, I put the card back. That makes it an independent event. Okay, so there we are, the probability. So I'm going to try and pick a diamond. No. Okay, did I get one the second time? No, no diamonds. Okay, So the probability, oops, I should have put that card back, shouldn't I? So the probability of me getting a diamond the first time is a 1 in 4 chance. I put that card back and then I try again. It's a 1 in 4 chance. So the probability of me picking out a diamond twice on the trot, okay, is 1 in 16, okay. Right, just have a go at some of the early questions in the textbook. They're pretty straightforward, okay, they're pretty straightforward. So it shouldn't take you too long, and then we'll move on to the tree diagrams. So on page 186, could you do question number 2? But I'd also like you, it's A, B, C, D, but I'd also want you to do E and F and use cross simplification, especially when you're doing E and F, please. And then do question 4 and question 5, please. Okay? Right, pause the video, have a go at those, and then we will carry on with the lesson. When you finish those, press play. Okay? Right, what I'd like us to look at now, on page 187 in the textbook, we've got the worked example. We've got the worked example there of how we draw a tree diagram. How we draw a tree diagram. So have a look at that, please. I've got here the yes/no cards. Okay, so we can have the yes and no cards. Right. So if you have a little look. Okay, the cards are shuffled, okay, and then you turn it over to see the probability of what card you're going to get. So let's have a little look. So here we have, so the probability of getting a yes, there are 3 yeses out of 5. The probability of getting a no is 2 out of 5. Okay, so these cards are turned over, okay, and they're shuffled, they're spun around, so we can see that the probability of picking one of those up. So we're going to do a tree diagram for that, okay. So let's have a little look. So our first attempt, okay, the probability of getting a yes is 3/5, 3 over 5, and the probability of getting a no is 2 over 5. Okay, and then we after that we're going to have a second go. Okay, we're going to have a second go, and these are the probabilities then with the second go. Okay, so the second attempt, and again the probability is 3/5 to get a yes and 2/5 to get a no. And this is what's in the book. Okay, you don't need to copy this out. And again, if we got a no first time, then on the second attempt, the probabilities remain the same of 3/5 for a yes and 2/5 for a no. So let's have a little look at the probabilities from here. So probability of my first go is 3 and 5 for a yes, 2 and 5 for a no. I've got a no. Okay, so I go down this route. Okay, I'm going to put that back. Now the probability again, because I've put this back, and it's now an independent attempt, the probability remains the same. So it's so again, I would turn this over. Oh, and this time it's gone for a yes. So to have gone down this route, I would have a 2 and 5 chance, then a 3 and 5 chance, and I would multiply those together in order to find the probability of me getting a no first and then a yes. Let's have a little look about so the probability is getting 2 yes cards. So the first probability of a yes card is 3/5. Okay, so we come to here. Then the second probability of a yes card is also 3/5. So remember, it's your 2 independent events, so we multiply those together. So that makes it a 9 in 25 chance that you would get yes and yes when you're doing these cards, okay? And the same if you get a no and no, okay? It's a 2 in 5 chance to get to there, another 2 in 5 chance, so that would be 2/5 times 2/5. That would be 4 in 25 chance of getting a no in your first one and then a no in the second, okay? The bit where it gets a little bit trickier, if you're asked what is the probability of getting one yes card and one no card. Now it doesn't say it has to be in any particular order. Okay, so the probability of getting a yes card first is 3 in 5, and then from there you get a no card. So you get a yes card, then a no card, which is a 2 in 5 chance, which means it's a 6 in 25 chance. But you could also remember, first of all, you could then go, your other option is you could get a no card first, which would be a 2 in 5 chance, and then a yes card, which would be a 3 in 5 chance. So again, we multiply those together, 6 over 25. Now what we do then, to find out the probability of getting one yes and one no, we would add these two together. Which would give me a 12 in 25 chance, okay? So that is the probability of getting one yes and one no. Sorry, it's a bit messy, okay? What I'd like you to do, have a look through that worked example. If you don't get it straight away, just take your time, read the extra parts about it, read the sort of the notes with it, and it'll help you, okay? And then can you have a go at this question, please? Have a go at this question. Right, draw a tree diagram showing the probabilities when tossing a coin twice. So you're going to toss a coin once, toss a coin again, okay? So find the probability. So you draw a tree diagram showing the probabilities, and then can you work out the probability of getting two tails, getting only one head, okay? Pause the video, have a go at that please, and then we'll carry on with the lesson. Right, let's have a go at this tree diagram for this. So again, here we have, so on our first attempt, okay, we have a half chance of getting a head and a half chance of getting a tail, and then we're going to go again, okay, on a half chance of getting a head, half chance of getting a tail, head, tail, and each of these are half chances. So the probability of getting two tails is a 1 in 2 chance to get to here, then another 1 in 2 chance, so it's a 1 in 2 times a 1 in 2, so it's a 1 in 4 chance of getting tails twice, okay, of getting tails on both coins, okay. Right, and then to get only one head, so we can go this way, we can have a head here, okay, which is a so we got if we go here, we got a 1 in 2 chance there, and then we can have a tail, okay, here, which is also 1 in 2 chance. So we've got a 1 in 4 chance going in this direction, and then the same down here, we're going to have a tail first, 1 in 2 chance, and then going up to get a head, a 1 in 2 chance. So that is also 1 in 4 chance. So that can happen twice, can't it? So in this case, we add those up, a half, a quarter, plus a quarter. So it's a 1 in 2 chance of getting one head, okay? Getting one head. Right, I feel as if I rushed through that quickly, but I've already gone through about 19-20 minutes of video. So I'll ask you to have a go at these. We will have a little revisit of them in the next lesson, okay? Right, could you then please, in that case, could you please have a go at, in your books, could you go on page 1887, question 6, page 188, question 7. Let me just check that. Yeah. Then have a little go, please. Page 193, question 1, page 194, question 3, and then have a go at the extension, page 197, question 13. Okay. Right, have a go at those. Any problems, please email me. And if needs be, we can have a little bit of a sort of a one-to-one Teams meeting just to go over something you're really struggling with. I'm going to generally do those during the lunch times. Okay, so good luck with that, and we'll carry on with this then next lesson. Okay, bye.